Well, we can fix the weird sound in post. Oh, geez. Hey, sorry. Welcome back to Machine Vision for the Visually Impaired Person, Chapter 2, Prehistory. Once again, sorry, I'm going to read mostly from a script and I'll just kind of improvise a little bit now and then, like I'm doing now. So in the first video, I talked about the history of the Echobatix app, mostly from 2019 to 2024. In this video, I'm going to talk about the prehistory, meaning before 2019. And I'm actually going to go back briefly to the 1930s. I wasn't alive then, but that's just to pick a point to start. And I'm going to be splitting this prehistory into two shorter videos. Feel free to skip ahead if this isn't your thing. But for vision developers in particular and students, I recommend sticking around and watching these two videos. I get literally $0 from your watching this. So I'm not asking you to do this to get likes or whatever, however this works. This is just a message I want to get out. And I really want to talk to people who are interested in vision and interested in assistive tech about these subjects, because I believe it's going to help you find work that you love, work that you're good at, work that you can get paid to do, all those things together. So I'm going to start with a book, Understanding and Applying Machine Vision by Nello Zuech, second edition. Nello is a well-known guy in the vision industry. Machine vision. Okay, and I'm going to explain what that means in a little while, why I'm not using the terms computer vision. Again, kind of interchangeable. I get really excitable about this kind of stuff sometimes. I'm probably the only person you'll met who gets this excitable, but I'll explain why, and you'll understand more later. Okay, so in chapter 2 of Nello's book here, which I received from John Echobatix some years ago, along with other engineers. Thank you very much for that, John. There is machine vision, historical perspective. So what I'm doing right now is holding up a book, and I'm showing just the page with chapter 2, machine vision, historical perspective. The concepts for machine vision are understood to have been evident as far back as the 1930s. Okay, that's enough from that book. I'm going to paraphrase here. So a company called Electronic Sorting Machines, according to Nello's book here, made light-sensitive machines to sort foods as far back as the 1930s. No digital cameras, no computers, but that's where machine vision can be said to start. Maybe Nello's found something else since the second edition. Anyways, we're going to skip over decades of really cool history, research, stuff in academia, industrial stuff, and we're going to jump up to 1971. Great year. And a company called Solid Photography, a machine vision company. Now, Solid Photography became Robot Vision Systems Incorporated, RVSI. Actually, I always thought it was Robotic Vision Systems Incorporated. Anyways, I worked for that company as an applications engineer from 1999 to 2005. Applications engineer, you might say, what the heck is that? It's kind of a sales engineer, kind of field engineer. Sometimes you write code. I wrote more code than the typical apps engineer. But we would travel around, and so this includes friends of mine and salespeople who are also friends, sorry. And we would travel around to different customers in different industries, find out what they wanted and make vision systems for them using our general purpose machine vision frameworks. Okay, now that was 1999 to 2005. Before that, my previous job was in R&D, actually, right out of school. And in that previous job, working in the auto industry for a company called AutoSpec, and then later Perceptron, I realized I wanted to know more about vision. I had grown up with cameras, taking pictures. Again, the vision thing, I was interested in vision. I don't see the 3D world the way most people do if they're sighted. So this stuff fascinated me. And my father was a very serious semi-pro photographer. It's not what he did for a living, but he did it for a long time, and or has done it for a long time. So I wanted to know more about this industry, and I realized that the best way to do this would be to be exposed to as many applications as possible in multiple industries. And maybe from there, I'd figure out how to specialize, but I wanted this experience. So I took an engineering job of that kind with RVSI. And as an apps engineer, I'd be working with salespeople and also with, development folks and so on. And a lot of these people are still my friends and good friends. So now at the time, RVSI was one of the bigger machine vision companies, but not as big and not as prominent as Cognex, which you can look, it's also here in the Boston area. Cognex is still the largest single company specializing in machine vision. But what's machine vision? Why am I not using the term computer vision? So briefly, digital image processing, big field, encompasses many subfields that have overlap. That includes machine vision, which you've heard me say, and which is part of the title of this series, computer vision, medical imaging, satellite imaging, or whatever it's called these days, including hyperspectral and multispectral image processing, and image editing as in apps like Photoshop and the open source alternative GIMP. Now, the Wikipedia entries about computer vision and machine vision, the last I checked, which I don't do too frequently. Now, they don't get the distinctions between these subfields quite right. And in my opinion, I guess I don't need to preface to say that, but they don't get these distinctions quite right for a variety of reasons. One, it's just anybody can edit these things. And yes, that works well in some cases, but not so great here. One is the relatively recent arrival of Wikipedia. I'm familiar with when Wikipedia started to get traction. I'll explain why a little later. That was relatively recently. I'd already been working for a number of years in machine vision before Wikipedia hit any kind of numbers where people were reading it widely. Also, there's the relatively recent popularity of the open source library OpenCV, which isn't that old. I remember version 1 when it came out, and we talk about it stuff in the field. So it's OpenCV, Open Computer Vision. It has its own history coming out of Intel and all this kind of stuff. Good stuff. Nothing against it, but it's just we're reinforcing it. It's like you've heard the book title, the phrase, "Don't think about an elephant." Say that, okay? When you hear the term computer vision over and over and over and over again, to some people it becomes that's what it is. Now, another thing is the use of the term computer vision, which has a long pedigree. It has spread from the classroom, from academia, where a lot of work has been done in image processing, and it's gotten into common use recently, largely because image processing can run on cameras on our mobile phones. Now, I'm just going to flip it back to machine vision. I'm just going to go ahead and claim this. And I would love to know a provable example, counterexample about this, but I'm going to go ahead and claim that every car, computer, passenger aircraft, pharmaceutical package, and just about any other major product you can name is inspected at least once, whereas industrial robots guided by machine vision systems. If you include working on raw materials, production of components, subassembly, assembly, and quality inspections, a manufactured product like the ones I've talked about, a pickup truck, your laptop, your mobile phone, may have been subject to hundreds or even thousands of measurements, checks, and inspections by these camera, computer, and other stuff-based systems called machine vision systems specifically, not computer vision. And those machine vision systems are more than a camera and software. Machine vision melds image processing, controls engineering, optics, and user interface design, and some other stuff, electronics and so on, in a way that makes it a distinct field. It's a field of its own because it requires knowledge of multiple disciplines, multiple elements working together. And if you lack one of those elements, your system won't work, and it won't work to the point you're not going to be able to sell it because no one's going to want it. If your system doesn't work well when the local lighting environment changes, surprise, you're not going to have a business. And that lighting thing is non-trivial. Oh, and also if someone says, you know what, this can only fail once every 3 months. And we're running 24/7, 24 hours a day, 7 days a week. That's not easy. And it's not just a lot of little easy work. No, it is complex. Think about that. You have to hit a percentage. We're talking statistics here. How do you predict that something can run for 3 months if you're only installing it for the first time? There's a statistical way to do that, demonstrate that this is possible. Anyways, you can specialize in machine vision. Machine vision companies and engineers, we have our own conferences. Companies like Cognex that I mentioned before, identify as machine vision companies. Even some of them, people will use the term computer vision once in a while. Now, there is a market in which customers compare machine vision systems from competing suppliers and then pick which system they think will work or is the right, cost benefit or whatever. And by market, I mean customers are talking to each other, right? There are places where they can go and buy, they can go online, they can compare notes with other people in the same industry, people, at different factories that belong to the same company. It's like, what did you buy? Did you buy this from this company or that company? What are we standardizing on? All those sorts of things. And vision companies they're much more like commodity systems these days for many, but not all applications. And that has changed over recent decades. Anyways, so that is one way to look at what machine vision systems are and the fact that they're machine vision companies. Now, if you disagree with this, it's fine, but it might be amusing to engage a little bit, uni, but realize, because this is my video, I'd ask half a dozen or more questions chosen from a long laundry list of interview questions I like to ask before we'd even begin. And one of the first ones, which this could be a good filter, if you've never made money selling at least a dozen vision systems, call them computer vision, whatever, there's probably no point in starting a discussion about terminology. We can still be friends. We can still be friends. Okay, now machine vision companies make factory systems that you may never see, which is fine. But these systems guide robots to build cars. They place computer chips and circuit boards in computers and can confirm that medicines are properly packaged. It's automated, right? Machine vision is vision specifically for industrial automation, sometimes for lab automation. Now, without machine vision, industrial automation, as we know it today, wouldn't exist, wouldn't work, period, at all. And that's also true of industrial robots and numerous types of sensors and all kinds of other equipment and sometimes thousands of people all working in one huge building to make just one product. Machine vision is just a small part of this. So all of those components are necessary. You need skilled workers. You need people coming from a variety of disciplines, engineers, people who know about paint, people who know about silicon, all kinds of things, right, to make each one of these individual products. There's a difference between, say, how Intel works and how Dell works. They build things differently. They're obviously interrelated, but it's a lot of people working hard, and they're all necessary. Machine vision is one component of this. And by the way, these companies buying these things, at least in my experience, call these things machine vision systems. More recently, especially with younger people, younger engineers, that may be changing, but it's okay. Now, of the subfields that I've mentioned of image processing, machine vision may be the grungiest, loudest, and most nerve-wracking, at least for widely deployed, widely used image processing systems. Now, computer vision systems may give you nightmares if you work on them. Trying to get your machine learning model to work, do what you want, especially if you're on some kind of deadline. Medical imaging, which is again related, different, that may tell you things or show you things about the inside of your body you really didn't want to know. Machine vision will give you physical scars and ulcers. Yay! Now, it's actually fun most of the time. Now, some newer engineers and even some older vision engineers that I've talked to or communicated with, working usually for specific kinds of organizations, maybe defense contractors, maybe they're more consulting firms, like, no more than 5, 6, 12 people doing specific kinds of applications. They may call their work computer vision. That's fine. I care more about this than most people. No one really cares. Now, the Echobatix app and its prototypes, I'm getting back to the, assistive tech development and the app. My company's app is a particular example. So the Echobatix app and its prototypes would employ what I would call computer vision, given the specific algorithms, the application, that is assistive technology for blind people running on a mobile device. And that's going to be true. It'll be a computer vision system for most of the features projected for future development. But My experience in machine vision prepared me to tackle problems a little differently. Remember I mentioned the thing about robustness. I'm not saying the app is as robust as I like it right now. I just know how to get there. And some machine vision-y work is going to make its way into the app. And of course, the user won't be aware of that and won't care, nor should they. User interfaces are a whole different subject. Okay, so that is just some discussion of the background, why I'm using the term machine vision, a little bit about its history, how it's different from computer vision, and how I've just hinted at how that plays into my history, because I'm talking about what could be important to you. Either you're a blind, visually impaired person, you kind of want to know how these things work. Maybe you can encourage someone else to develop some new tech, and you can say, hey, look at this video. This might help you to develop some new assistive tech. Or you're a student or an engineer, you maybe just think about getting into computer vision. It's okay. You don't have to call it machine vision. You don't have to get into machine vision, but I'm going to be talking about both. But I've called this machine vision for the visually impaired person because I have more experience in machine vision. I know what it is well. And I also just like the way it rolls off the tongue. Machine vision for the visually impaired person. Visually impaired person like me. We'll pick this up again in the next video. Until then, thanks so much for watching.